Hello and welcome to EGN 3613. In this session we will continue with calculating different cash flows under inflation. So far we learned that inflation F is a percent per time period similar to an interest rate during an period of time. In addition, we learned that future dollars are equal to today's dollars multiplied by 1 plus average inflation rate to the power n. Today's dollars is the constant dollars that we have in our hand, which can be converted into actual dollars if we considered inflation. Let's look at the following example. A firm would like to purchase a productive asset that costs 2,000 or 209,000 in today's dollars. If the inflation rate is 4% per year, what will be the cost of the same piece of equipment 10 years from now? Using the formula, 209,000 multiplied by 1.04 to the power 10 will equal to $309,371. Even at modest 4% rate of inflation, the future impact on cost is significant. This example does not consider the time value of money. Actually, a proper engineering economy analysis should consider both inflation and the time value of money. To consider both inflation and time value of money, we need to include three important rates: real or inflation-free interest rate, and we can have a notation of I prime, inflation-adjusted rate or IF, and inflation rate. So the real or inflation-free interest rate is the rate at which interest is earned, and the effects of any inflation has been removed. Actually, it represents the real gain received or charged on investment or borrowing. The I sub F, or the I, is the inflation adjusted interest rate, or what we call market interest rate, which is the combination of the real interest rate I prime and the inflation rate F. In some books might be called the inflated interest rate. Inflated means we considered inflation within that, or adjusted the inflation within the interest rate. The inflation rate F is the measure of the rate of change in the value of currency, which is a percentage value similar to an interest rate but should not be confused as an interest rate. In previous examples, calculating the present worth was through assuming that all cash flows were in constant value dollars. How could it be done if we would like to consider both inflation and interest? And for example, if we have 5,000 inflated at 4% per year with interest rate of 10% per year. So we have inflation and we have time value money. Using the formula, P will equal to F multiplied by 1 plus 0.1 to the power minus n. With future constant value of 5,000, interest rate of 10%, and number of periods is 1 for the first year, the present worth at real interest rate will equal to 4,545. And after 4 years, it will equal to 3,415. How did we solve the problem like that? Let's try again, but first let's find a combined interest rate that will combine inflation and real interest rate. In other words, we are trying to find the value of I sub f, which is the interest with adjusted or adjusted under inflation, or we can say inflation adjusted interest rate. We are going to start with our famous equation as usual, which is P is equal to F multiplied by 1 divided by 1 plus I to the power N. Assuming that I is the real interest rate in this formula. If we would like to assume that actually F is the future dollar amount with inflation built in, then P is equal to the future value divided by 1 plus F, and that's the inflation included, to the power N, multiplied by 1 divided by 1 plus I, which is the real interest, to the power N. So multiplying the denominators in the equation will make the equation look like P equal to F multiplied by 1 divided by 1 plus I plus F plus I plus F, or multiplied by F to the power N. And I want you to note this, that this is not F, this is IF. This is I and this is F. I is the real interest, which is this one, I, and F is the inflation factor or the inflation rate, and this is F, and all to the power N. So IF in this case is called market interest rate or inflated interest rate, which is equal to IF will be equal to I prime plus F plus I prime F. Then P will equal to F multiplied by 1 plus IF to the power N. And that will be the new calculation or the new formula using the new adjusted interest. And it can be written differently, which is it can be written as F multiplied by the factor, and the factor is P given F with the adjusted interest IF and number of periods N. Reworking our example with real interest rate of 10% per year and inflation rate of 4% per year, we will find that IF is equal to 0.144 or 14.4% per year. Using the cost future dollars, which is 5,849, and multiplying by the present worth factor, the present worth factor is 0.5838, will equal, the multiplication will equal to 3,415. Let's look at another example. If F, the inflation, is equal to 12% per year, and the interest rate I prime is equal to 15% per year, IF will equal to 0.15 plus 0.12 plus 0.15 multiplied by 0.12, which will equal to 0.0288. So the IF, or the adjusted interest, will be equal to 28.8% per year. How about the future worth analysis? Does it have different calculations? This section deals with solving F, which takes into consideration the inflation and the real interest. There are four different interpretations for future worth calculations. First, using the actual future dollar. Second, using the purchasing power of the future dollars. The future dollar required at time or t equal to n to maintain t equal to 0 purchasing power. The dollar at t equal n to maintain purchasing power and earn a stated interest rate of I% per time period. To solve, we use the equation, which is future value is equal to P multiplied by 1 plus IF, and IF now it's the adjusted rate to the power n, and also it can be written as P multiplied by the factor, which is F given P with IF and n number of period, and we apply the formula for the IF to calculate that value, and this is the actual dollar at time t. Let's look at the following example to understand how it works. If P is equal to 1000 now and the market rate of interest is 10% per year, with F is equal to 4% per year. Now remember that the market rate of interest includes both the inflation rate and the interest rate. When we say market rate, that means it's included, the inflation is included. So I don't need to change or make any calculation. So if n is equal to 7, what's the future value of 1000? The future value will equal to 1000 multiplied by the factor, which is F given P with 10% and 7 periods, and that will equal to $1,948. If we calculate the constant value for this example, then we need to remember that F after 7 years with 10% including inflation is equal to 1,948. Deflating that value at inflation rate of 4% will equal to F, which is 1,948 divided by 1.04 to the power 7, and that will equal to $1,481. Looking at that, you can see that the 1,481 is 24% less than the $1,948. So inflation reduces the purchasing power by almost 24% over the 7 years for this amount or for this type of product. Given a market rate of interest IF and the inflation rate of F, find the real interest rate for a certain amount. Can we do that, or can we use the same formula to do that? Yes, and as you can see what we did with a little algebra, again we reformulated our formula to look like what we have here in the slide, which is I equal to IF minus F divided by 1 plus F, and I here is the real interest rate. So given IF is equal to 10% and F is equal to 4%, find the real interest rate for this case. To find the real interest rate for a market rate of 10% and inflation of 4%, we solve using the formula, and we get I is equal to, or I prime is equal to 0.1 minus 0.04 divided by 1 plus 0.04, which will equal to 0.0577. And that is 5.77%. So f is equal to 1000 multiplied by the factor, which is f given p, with interest of 5.77% and 7 periods, and that will equal to $1,481. So the inflation of 4% per year has reduced to a real rate to less than 6% per year. Instead, it's 5.77%. With inflation, prices and costs increase over time. The future dollar are worth less out in time. At t equal n, more dollars are needed. We only need to apply the inflation rate to the present sum. F is equal to P multiplied by 1 plus F to the power n, and that's how we got the $1,316. If we went to our calculations for the example and try to work backward to find IF with P equal to 1000 and F is equal to 4%, the real interest rate of 5.77%, we can substitute these values to find IF, and we will find that IF will equal to 10% or 0.1. Then F will equal to 1000 multiplied by F given P with 10%, 7 periods, and that is equal to 1948, which is the same value that we got before. So as you can see, we can use the calculation now, or we need to actually calculate our values considering inflation and considering the time value money. That will be all for this session. If you have any questions, you can email it to me, or you can ask me through any communication channel. Thank you and have a great day.